Close your eyes for a moment and imagine yourself standing in the vast darkness of an Arctic night. The air is crisp and still, cold enough that each breath forms a small cloud of vapor that dissipates into the blackness. Above you the stars shine with a clarity impossible to see from cities, each one a sharp point of light against the infinite dark. And then, slowly, almost imperceptibly at first, something changes. A faint glow appears on the northern horizon. It's not the glow of distant city lights or the approaching dawn, but something else, something ethereal, luminous, alive. The glow strengthens, spreads, begins to move. Curtains of light unfurl across the sky, shimmering in shades of green so pure they seem to belong to another world. The curtains ripple and wave as if caught in a celestial breeze, though the air around you remains perfectly still. This is the Aurora Borealis, the northern lights, one of nature's most beautiful and mysterious displays. What you're witnessing in this moment is actually a visible manifestation of invisible cosmic forces, a delicate interaction between our sun, Earth's magnetic field, and the thin atmosphere that surrounds our planet. The lights dancing above you are the visible evidence of Earth's constant protection from the harsh environment of space, a testament to the magnetic shield that makes life on our planet possible. Let's understand what creates this phenomenon, this bridge between Earth and space that has captivated human observers for millennia. The story begins 93 million miles away, at our sun. The sun is not a calm, stable sphere, but a roiling mass of plasma, ionized gas so hot that electrons are stripped from atoms, creating a sea of charged particles. The sun's outer atmosphere, called the corona, reaches temperatures of millions of degrees Celsius. At these extreme temperatures, the sun's gravity cannot completely hold on to the outer layers of its atmosphere. Particles escape constantly, streaming outward into space in all directions. This outflow of charged particles, mostly protons and electrons, is called the solar wind. It's a continuous breeze of plasma flowing from the sun at speeds between 400 and 800 kilometers per second, filling the entire solar system with a thin but constant stream of matter. The solar wind carries with it fragments of the sun's magnetic field, creating an interplanetary magnetic field that pervades the space between planets. When this solar wind reaches Earth, traveling at these tremendous velocities, it encounters our planet's magnetic field, the magnetosphere, a vast invisible bubble extending tens of thousands of kilometers into space. This magnetic field is generated deep within Earth, in the outer core where molten iron circulates in complex patterns, creating electrical currents that generate magnetic fields through a process called the geodynamo. The magnetosphere acts as a shield, deflecting most of the solar wind around Earth like water flowing around a rock in a stream. But the interaction isn't perfect. Some solar wind particles manage to enter Earth's magnetic environment, particularly near the magnetic poles where the field lines converge and funnel down toward the surface. These particles are guided along the magnetic field lines, spiraling downward into the upper atmosphere at altitudes between 100 and 300 kilometers above Earth's surface. These charged particles, moving at tremendous speeds, carrying significant energy, collide with atoms and molecules in the atmosphere. Earth's atmosphere at these altitudes is extremely thin, far thinner than the air you breathe, but it contains oxygen atoms, nitrogen molecules, and other gases. When the energetic solar wind particles strike these atmospheric atoms, They transfer their energy through collision. This energy transfer excites the atmospheric atoms, meaning electrons in those atoms are bumped up to higher energy states. But these excited states are unstable. Within fractions of a second, the electrons fall back down to their original energy levels, and when they do, they release the excess energy as photons, particles of light. This is the light you see when you watch the aurora. Each photon released by an atmospheric atom contributes to the glowing curtains dancing across the sky. Different atmospheric gases emit different colors of light when excited. Oxygen atoms, which are abundant at altitudes around 100 to 150 kilometers, emit a distinctive green light, the most common aurora color, the one you see most frequently in aurora displays. At higher altitudes, above 200 kilometers, where the atmosphere is even thinner, and oxygen atoms are more spread out, those same oxygen atoms can emit a rare deep red light. Nitrogen molecules, when excited, produce blue and purple hues, adding variety to the aurora's color palette. The result is a light show of extraordinary beauty and complexity. The aurora typically appears as curtains or sheets of light stretching across the sky, but it can also take the form of arcs, rays, or diffuse glows. The lights shimmer and dance, changing intensity and position as the solar wind varies, as Earth's magnetic field responds to that variation, as different atmospheric gases at different altitudes are excited by the incoming particles, and remarkably, despite this cosmic violence, particles traveling at hundreds of kilometers per second, collisions energetic enough to excite atoms, light being generated through quantum mechanical processes, the aurora is silent. Standing beneath the northern lights, you hear nothing. The display is purely visual, a soundless dance of color and motion playing out in the near vacuum of the upper atmosphere where there's not enough air to carry sound waves. This silence contributes to the aurora's meditative quality. There's something deeply peaceful about watching these lights move across the sky, about witnessing cosmic forces manifesting as gentle beauty rather than destruction. The aurora reminds us that we live on a protected world, that Earth's magnetic field is constantly at work shielding us from the solar wind that would otherwise strip away our atmosphere, that the same forces that could be harmful instead create something achingly beautiful. Throughout this exploration, we're going to follow the aurora's story from beginning to end. We'll travel from the sun's corona, where the solar wind originates, across millions of miles of space, through Earth's magnetic shield, down into the upper atmosphere where light is created, and finally to the ground where human observers have been watching and wondering for thousands of years. We'll understand the physics that creates the lights, but we'll also appreciate the mystery and beauty that scientific understanding enhances rather than diminishes. The aurora is many things simultaneously, a scientific phenomenon that can be explained through physics and chemistry, a protective mechanism that reveals Earth's magnetic shielding, a connection between our planet and the sun, and a source of wonder that has inspired myths and legends across cultures. It's a reminder that we live in a dynamic solar system where the sun constantly influences Earth, where invisible forces shape our environment, where beauty emerges from the interaction of matter and energy. As we journey through this story, let the pace be unhurried. The solar wind takes days to travel from sun to Earth. The particles spiral slowly along magnetic field lines. The lights dance at their own rhythm, not rushed, not urgent, simply being. Match your breathing to this patient cosmic pace. Feel yourself relaxing into the story, allowing it to unfold naturally, like the aurora itself unfolding across the polar sky. We begin our journey at the source, at the sun itself, where it all starts. Let us travel now to the sun, that brilliant sphere that dominates our daytime sky, that provides the light and warmth that makes life on Earth possible. But we're not interested in the sun's visible surface today. We're going deeper, or rather higher, into the sun's outer atmosphere, the corona, where the solar wind is born. The corona is one of the sun's most mysterious features. If you've ever seen a total solar eclipse, you've witnessed the corona. That pearlescent halo of light surrounding the darkened disk of the moon as it blocks the sun's bright surface. The corona appears delicate, almost gossamer, with streamers and loops of glowing gas extending millions of kilometers into space. But this delicate appearance belies the corona's true nature. It's a realm of extreme temperatures and violent activity. The temperature in the corona reaches between 1 and 3 million degrees Celsius. This is paradoxical and still not completely understood. The sun's visible surface, the photosphere, is only about 5,500 degrees Celsius, yet somehow the atmosphere above it is hundreds of times hotter. This heating appears to be caused by magnetic activity, by the constant reconnection and snapping of magnetic field lines that thread through the sun's atmosphere, converting magnetic energy into heat. At these extreme temperatures, atoms cannot hold onto their electrons. The intense thermal energy strips electrons away, creating a plasma, a state of matter where positively charged nuclei and negatively charged electrons move independently. For the corona, this means a sea of protons, hydrogen nuclei, electrons, and smaller amounts of heavier elements, all ionized, all moving at tremendous speeds dictated by the extreme temperature. The sun's gravity is powerful. 330,000 times Earth's mass creates a gravitational pull that holds the entire solar system in orbit. But at the corona's extreme temperatures, particles are moving so fast that some achieve escape velocity. They break free from the sun's gravitational embrace and stream outward into space. This continuous outflow is the solar wind. Imagine standing at the edge of the corona, if such a thing were possible, watching this process. All around you, particles are escaping upward. Not all of them, but a steady stream, like water evaporating from a heated surface. Protons and electrons accelerate away from the sun, pushed not just by thermal energy but also by the pressure of the hot corona itself, creating a supersonic flow that extends throughout the solar system. The solar wind travels at speeds between 400 and 800 kilometers per second, roughly 1 to 2 million miles per hour. At these velocities, the solar wind crosses the 93 million miles between Sun and Earth in about 3 to 5 days. This is much slower than light, which makes the journey in just 8 minutes. So we see changes in the sun's appearance before we experience their effects on Earth. When you see a solar flare through a telescope, you know the effects will reach Earth in a few days. The solar wind is not uniform or steady. Sometimes it flows gently, a calm breeze carrying relatively few particles at moderate speeds. Other times it surges into a gale, driven by events on the sun's surface. These more violent episodes are what create the most spectacular auroras. The sun experiences periodic outbursts called coronal mass ejections, or CMEs. These are massive eruptions where billions of tons of plasma are flung into space in enormous clouds, traveling faster than the background solar wind. A CME can carry as much mass as a small mountain, all of it ionized gas moving at speeds up to 3,000 kilometers per second. CMEs are often associated with solar flares, intense brightening of regions on the sun's surface caused by magnetic energy release. The magnetic fields in the sun's atmosphere become twisted and stressed by the roiling motion of plasma beneath the surface. When these fields become too stressed, they snap and reconnect in new configurations, converting magnetic energy into kinetic energy, heat, and radiation. The plasma caught in these reconnecting field lines is heated to tens of millions of degrees and ejected violently outward. When a CME is directed toward Earth, when it erupts from a region of the sun that happens to be facing our planet at the time, we experience what's called a geomagnetic storm when it arrives days later. The enhanced solar wind from the CME compresses Earth's magnetosphere, disturbs the magnetic field, and funnels more particles than usual into the polar regions. These are the times when auroras become most intense, when they can be seen at lower latitudes than usual, when the lights fill the entire sky with dancing color. The journey of solar wind particles from Sun to Earth is mostly empty and silent. Space between the planets is nearly a perfect vacuum. There might be only 5 particles per cubic centimeter in the solar wind near Earth's orbit compared to about 10 to the power of 19 particles per cubic centimeter in the air you breathe. This means the solar wind is extraordinarily diffuse, more like a barely perceptible mist than the dense matter we're familiar with on Earth's surface. The particles travel in straight lines once they escape the sun, moving through the vacuum of space with nothing to slow them down or deflect them. Well, almost nothing. They do interact with the sun's magnetic field, which threads through space carried along by the solar wind itself. This creates the interplanetary magnetic field, a complex structure that varies with the sun's rotation and activity. The sun rotates, letting one turn about every 27 days as seen from Earth, about 25 days at the equator, longer at the poles. The sun doesn't rotate as a solid body. As it rotates, the magnetic field carried by the solar wind gets wound into a spiral pattern like water from a rotating sprinkler. The spiral is called the Parker spiral, after the physicist Eugene Parker, who predicted both its existence and the existence of the solar wind itself in 1958. These predictions were revolutionary at the time. Many scientists believed space was empty, that nothing flowed continuously from the sun. But Parker's theoretical work showed that the corona's high temperature must result in a continuous outflow, and that this outflow would carry the sun's magnetic field in a spiral pattern. The predictions were confirmed in the 1960s by spacecraft measurements, and Parker lived to see the Parker Solar Probe, named in his honor, the first spacecraft named for a living scientist, launch in 2018 to study the very regions of the corona where the solar wind originates. The Parker Solar Probe has provided unprecedented measurements of the solar wind's birth, flying closer to the sun than any previous spacecraft. Diving through the corona itself, the probe has measured the temperature, density, and magnetic field of the solar wind at its source. These measurements are helping scientists understand exactly how the corona reaches such extreme temperatures and how that heat translates into the continuous outflow of particles as the solar wind particles travel from sun to Earth. They have no awareness of their destination, no knowledge that they're heading toward a planet with a magnetic field. They simply flow outward, pushed by the pressure of the hot corona, moving at supersonic speeds through the near vacuum of interplanetary space. Most will miss Earth entirely. Our planet is a tiny target in the vast expanse of the solar system. The solar wind spreads in all directions, and only a minuscule fraction happens to encounter Earth's magnetosphere. But for those particles that do intersect Earth's orbit at just the right time and place, an interaction awaits. After days of travel through empty space, they're about to encounter something new. A magnetic field, a protective bubble, an obstacle in their path. They don't know it yet, but this encounter will result in some of them being redirected, guided along invisible field lines, accelerated to even higher energies, and ultimately sent spiraling down into Earth's atmosphere, where they'll create light. The solar wind is constant, has been flowing for the sun's entire 4.6 billion year lifetime, and will continue flowing for another 5 billion years, until the sun exhausts its hydrogen fuel and begins to die. Every second of every day, whether you can see the sun or not, whether it's day or night where you stand, the solar wind is flowing past Earth, interacting with the magnetosphere and creating the conditions for auroras to appear. There's something meditative about contemplating this constancy. While you sleep tonight, the solar wind continues its journey. While you go about your daily life, particles are streaming from the sun toward Earth. The process never stops, never pauses, operating on timescales that dwarf human concerns. The solar wind was flowing before humans existed and will continue long after we're gone. A fundamental feature of our sun's nature. This perspective brings peace. You're part of a solar system in constant motion, constant interaction. The sun breathes out particles. Earth's magnetic field responds. Light appears in polar skies, all of it happening whether you think about it or not, whether you understand it or not, governed by physical laws that operate with perfect reliability and patience. Rest now in this knowledge. The solar wind flows. In 3 to 5 days, particles leaving the sun right now will reach Earth. Some will be deflected harmlessly around the magnetosphere. Others will be funneled toward the poles. Light will be created. The aurora will dance. And through it all, you can rest peacefully, protected by Earth's magnetic shield, living on a planet that transforms solar wind into beauty. Breathe slowly, like the patient flow of the solar wind across millions of miles of space. Let your thoughts drift outward with those particles, moving through the peaceful emptiness between sun and Earth. Approaching the next stage of the journey, the encounter with Earth's magnetic field, the invisible shield that shapes their path and determines their ultimate fate. The solar wind particles have traveled for days across the vast emptiness of space, and now they approach their destination. Earth hangs before them, a blue and white sphere, beautiful against the blackness. But before the particles can reach the planet itself, before they can strike the atmosphere or surface, they encounter something invisible yet powerful. Earth's magnetic field, the magnetosphere, a vast protective bubble that surrounds our planet and shields it from the full force of the solar, our wind. This magnetic field is one of Earth's most important features. Absolutely essential for maintaining the conditions that allow life to flourish. Yet it's completely invisible, undetectable to human senses, operating silently and constantly without any conscious thought or maintenance. Understanding this field, where it comes from, how it works, what it does, helps us appreciate the elegant systems that make our planet habitable. Let's journey to the source of Earth's magnetic field, deep inside our planet, nearly 3,000 kilometers below the surface. Here, at the boundary between the rocky mantle and the metallic core, conditions are extreme. Temperatures reach about 4,000 degrees Celsius, comparable to the sun's surface. Pressure is millions of times greater than at Earth's surface, and despite these temperatures being well above the melting point of iron at normal pressure, the inner core is solid, kept in that state by the immense pressure, but surrounding this solid inner core is the outer core, a shell of liquid iron and nickel about 2,300 kilometers thick. This outer core is not static, it's in constant motion, stirred by several forces. Heat escaping from the even hotter inner core creates convection currents, like water boiling in a pot. Earth's rotation organizes these currents through the Coriolis effect, creating preferential flow patterns. And the slow crystallization of iron onto the solid inner core releases heat and light elements, driving additional circulation. This flowing liquid iron is electrically conductive. Electrons can move relatively freely through the metallic fluid. When this conductive fluid moves through existing magnetic fields, it generates electric currents through electromagnetic induction, the same principle that makes electrical generators work. These electric currents flowing through the conducting iron create their own magnetic fields, and these magnetic fields affect the flow of the iron, which changes the electric currents, which modifies the magnetic fields, creating a self-sustaining cycle. This is the geodynamo, a natural dynamo operating in Earth's core, converting the kinetic energy of flowing liquid iron into magnetic energy, generating the field that extends from deep inside Earth out into space. The process has been operating for at least 3.5 billion years, probably longer, continuously generating the magnetic field that protects our planet. The field that emerges from this deep Earth process has a particular shape. If you could somehow see magnetic field lines, you'd observe them emerging from Earth's south magnetic pole, arcing through space in graceful curves and re-entering at the north magnetic pole. This is a dipole field, similar to the field around a bar magnet, with two poles and field lines connecting them. But this field doesn't exist in isolation. It exists in the flow of the solar wind, and this interaction profoundly shapes the magnetosphere structure. On the side of Earth facing the Sun, the solar wind compresses the magnetic field, pushing it closer to the planet. The magnetosphere extends only about 60,000 to 65,000 kilometers sunward, still vast by human standards, about 10 Earth radii, but compressed compared to what it would be without the solar wind's pressure. On Earth's night side, away from the Sun, the opposite occurs. The solar wind stretches the magnetic field into a long tail called the magnetotail, extending hundreds of Earth radii downstream, perhaps millions of kilometers, far beyond the Moon's orbit. This magnetotail is where much of the magnetic energy from solar wind interaction gets stored, and it plays a crucial role in creating intense auroras during geomagnetic storms. The overall shape of the magnetosphere is thus asymmetric, compressed and rounded on the sunward side, elongated into a tail on the night side, like a teardrop or a comet. This shape is dynamic, constantly adjusting as the solar wind varies in speed and density, as Earth rotates beneath the field, as magnetic reconnection events transfer energy between the solar wind's magnetic field and Earth's. The first boundary the solar wind encounters is called the bow shock. This is analogous to the sonic boom created by a supersonic aircraft. When the solar wind, traveling supersonically through the tenuous interplanetary plasma, encounters the obstacle of Earth's magnetosphere, it must slow down abruptly. This creates a shock wave, a standing wave in space where the solar wind particles decelerate from supersonic to subsonic speeds, heating up in the process. Behind the bow shock is a region called the magnetosheath, a turbulent transition zone where slowed solar wind plasma flows around the magnetosphere. The magnetosheath is chaotic, filled with magnetic turbulence and varying plasma density, like the wake behind a boat but in 3 dimensions, and filled with charged particles and tangled magnetic fields. Then comes the magnetopause, the actual boundary of the magnetosphere, the surface where Earth's magnetic pressure balances the solar wind's ram pressure. This is not a hard boundary like Earth's surface, but rather a thin layer, perhaps a few hundred kilometers thick, where the transition occurs. Inside the magnetopause, Earth's magnetic field dominates. Outside, the solar wind dominates. The solar wind cannot easily cross the magnetopause. Its charged particles are deflected by the magnetic field, guided around the magnetosphere like water flowing around a rock. Most solar wind particles never enter Earth's magnetic environment at all. They're simply pushed around the obstacle and continue their journey out into the wider solar system, but the interaction isn't perfect. Through a process called magnetic reconnection, some solar wind energy and particles can enter the magnetosphere. Magnetic reconnection occurs when magnetic field lines from the Sun, carried by the solar wind, encounter Earth's magnetic field lines at the magnetopause. If the field lines are oriented in opposite directions, they can break and reconnect in a new configuration, creating a bridge that allows solar wind particles to flow across the magnetopause and enter Earth's magnetic environment. This reconnection is especially efficient when the solar wind's magnetic field points southward, opposite to Earth's northward pointing field at the equator. During these times, reconnection on the dayside magnetopause allows particles to enter, and reconnection in the magnetotail releases stored magnetic energy, accelerating particles toward Earth at high energies. These are the conditions that create the most intense auroras. Particles that enter the magnetosphere don't have free rein to go wherever they want. They're constrained by the magnetic field, forced to follow the field lines. Charged particles moving through magnetic fields experience a force, the Lorentz force, that acts perpendicular to both their motion and the magnetic field direction. This force causes the particles to spiral around the magnetic field lines, corkscrewing along the lines like beads, sliding along curved wires. Near the equator, magnetic field lines arc through space far from Earth, and particles bounce back and forth along these field lines, creating the Van Allen radiation belts, regions where energetic particles are trapped, spiraling along field lines and reflecting back when they approach Earth's atmosphere at higher latitudes. These radiation belts were one of the first major discoveries of the space age, detected by instruments on Explorer 1, America's first satellite, in 1958. But nearer the poles, magnetic field lines converge and funnel down toward Earth's surface. Particles spiraling along these field lines are guided into the upper atmosphere at high latitudes, typically in an oval-shaped region around each magnetic pole called the auroral oval. This is why auroras occur at high latitudes, why they're most commonly seen in a band roughly 3,000 to 6,000 kilometers from the magnetic poles. The auroral oval isn't fixed in place. It expands and contracts depending on geomagnetic activity. During quiet times when the solar wind is calm and little reconnection occurs, the oval is small, perhaps reaching down to latitudes around 65 or 70 degrees. During geomagnetic storms, when reconnection is vigorous and energy floods into the magnetosphere, the oval expands dramatically, sometimes reaching down to 50 or even 40 degrees latitude. This is when auroras become visible from locations normally too far from the poles to see them. When northern lights appear over Scotland or northern United States, when southern lights are visible from southern Australia or New Zealand, Earth's magnetic field has additional important effects beyond shaping the aurora. It protects the atmosphere from erosion by the solar wind. Without the magnetic shield, solar wind particles would interact directly with atmospheric atoms, imparting enough energy to allow some to escape to space. Over geological time, hundreds of millions or billions of years, this process could strip away significant amounts of atmosphere. We see evidence of this on Mars. Mars once had a global magnetic field similar to Earth's, but about 4 billion years ago, Mars's small core cooled enough to solidify, shutting down the dynamo. Without magnetic protection, the solar wind has been steadily eroding Mars's atmosphere for billions of years. Current Mars has atmospheric pressure less than 1% of Earth's, not enough to support liquid water on the surface, a stark demonstration of what can happen to a planet that loses its magnetic shield. The magnetic field also creates the radiation belts that, while hazardous to spacecraft and astronauts, actually protect the surface by trapping and containing high-energy particles that might otherwise penetrate deeper into the atmosphere. The field deflects cosmic rays, high-energy particles from outside the solar system, reducing surface radiation levels compared to what they'd be without the field. And of course, the magnetic field creates the auroras, those beautiful lights that make visible the invisible processes protecting our planet. The aurora is simultaneously a scientific phenomenon to be understood, a protective mechanism to be appreciated, and a source of beauty to be wondered at. Every aurora you see is evidence of Earth's magnetic shield doing its job, deflecting solar wind, guiding particles, protecting the atmosphere, maintaining conditions for life. There's something deeply comforting about understanding this protection. Earth is shielded. The magnetic field operates continuously day and night, year after year, century after century, requiring nothing from us. It's a gift of planetary structure and composition, of having a large enough iron core that remains molten, of rotating fast enough to organize the fluid motion into field-generating patterns. Rest now in the knowledge of this protection. Feel yourself surrounded by an invisible shield, a magnetic bubble extending tens of thousands of kilometers into space, deflecting harmful particles, creating beauty from what could be destruction. The magnetosphere is working right now, this very moment, as it has for billions of years, as it will for billions more. Let this understanding deepen your relaxation. You are protected. The systems that sustain you operate without your conscious thought. The magnetic field turns the solar wind into auroras, transforms potential harm into luminous beauty. Trust in this protection. Rest in its constant operation. Allow yourself to be held safely within Earth's magnetic embrace. The solar wind particles have traveled millions of miles, been guided by Earth's magnetic field, and now they spiral downward along magnetic field lines toward the polar regions. Their journey is nearly complete, but the most visible part The creation of light itself is about to begin. Let us slow down time and watch carefully as these particles enter Earth's atmosphere and create the aurora through a beautiful dance of atomic physics. The atmosphere at auroral altitudes, between 100 and 300 kilometers above Earth's surface, is vastly different from the air you breathe. At sea level, the atmosphere is dense, containing about 10 to the power of 19 molecules per cubic centimeter, creating the pressure we measure as 1 atmosphere. But at 100 kilometers altitude, the density has dropped to about 10 to the power of 12 molecules per cubic centimeter, 1,000,000 times less dense. At 300 kilometers, it's 10 to the power of 8 molecules per cubic centimeter, 100 billion times less dense than sea level. This is the threshold of space, the region where the atmosphere transitions from being relatively dense and collision-dominated to being so thin that particles can travel long distances without hitting anything. Yet even at these low densities, there are enough atmospheric atoms and molecules to create the spectacular light displays we call auroras. The composition of the atmosphere also changes with altitude. At sea level, the atmosphere is about 78% nitrogen, N2 molecules, 21% oxygen, O2 molecules, and small amounts of other gases. But at auroral altitudes, ultraviolet radiation from the sun has broken apart many of the oxygen molecules, creating atomic oxygen, individual oxygen atoms rather than the O2 molecules we breathe. Nitrogen remains mostly as N2 molecules, though some atomic nitrogen exists as well. This mixture of atomic oxygen, molecular nitrogen, and molecular oxygen is what creates the aurora's colors. Each type of atom or molecule, when excited by colliding solar wind particles, emits light at characteristic wavelengths determined by its quantum mechanical structure. Understanding these emissions helps us appreciate both the physics underlying the aurora and why the lights appear in the colors they do. Picture now a solar wind particle. Let's follow a single electron, spiraling down along a magnetic field line, approaching the atmosphere. This electron has been accelerated to high energies, perhaps several thousand electron volts, as it was captured and energized in Earth's magnetosphere. It's moving fast, a significant fraction of the speed of light, carrying substantial kinetic energy. As the electron enters denser regions of the atmosphere, it begins encountering atmospheric atoms and molecules more frequently. At first, the encounters are rare. The atmosphere at 300 kilometers is still very thin. But as the electron descends, spiraling along the field line, the air density increases and collisions become more common. When the energetic electron collides with an oxygen atom, several things can happen depending on the collision's exact geometry and energy. In many cases, the electron transfers some of its energy to an electron in the oxygen atom, bumping that atomic electron up to a higher energy level, an excited state. The oxygen atom now has more energy than its stable ground state configuration, and this excess energy must be released somehow. The atom doesn't remain excited for long. Within fractions of a second, the excited electron falls back down to its ground state. As it does, the atom must dispose of the excess energy. And it does this in the most elegant way possible, by emitting a photon, a particle of light. The photon's energy, and therefore its color, is determined by the exact energy difference between the excited state and the ground state. For oxygen atoms at altitudes around 100 to 150 kilometers, the most common emission is at a wavelength of 557.7 nanometers. This wavelength corresponds to green light, the color that dominates most aurora displays. When you see green aurora curtains shimmering across the sky, you're seeing millions upon millions of oxygen atoms, each one excited by colliding particles, each one falling back to ground state and emitting a green photon. The collective effect of countless individual atomic emissions creates the luminous green glow. But oxygen can emit other colors too, and this is where altitude becomes crucial. At very high altitudes, above 200 or 250 kilometers, where the atmosphere is extremely thin, oxygen atoms can be excited to a different higher energy state. When these atoms relax back to ground state, they emit light at 630 nanometers, which appears as deep red to human eyes. This red aurora is less common than green because it requires specific conditions, high-altitude collisions, and enough time for the atoms to emit before colliding with other particles and losing their energy through non-radiative processes. Red auroras are hauntingly beautiful, often appearing as a diffuse glow above the brighter green curtains, sometimes filling the sky with crimson light during intense geomagnetic storms. The red emission is weaker than green because the transition that creates it is forbidden in quantum mechanical terminology, meaning it's unlikely to occur, so the excited state is long-lived. At lower altitudes where collisions are more frequent, excited oxygen atoms lose their energy through collisions before they can emit red light. Only at high altitudes where collisions are rare does the red emission become visible. Nitrogen molecules add blue and purple hues to the aurora's palette. When energetic particles collide with N2 molecules, they can excite the molecules to various states. Nitrogen emissions are more complex than oxygen because molecules have more ways to be excited, not just electronic transitions, but also vibrational and rotational states. The result is emission across a range of wavelengths. Ionized nitrogen, N2 plus molecules that have lost an electron, emits blue light at wavelengths around 428 nanometers and red to purple light at 650 to 680 nanometers. Neutral nitrogen molecules emit light in the ultraviolet and in the red. The combination creates the blue and purple fringes often seen at the lower edges of bright aurora curtains, adding complexity and beauty to the color palette. The intensity of the aurora, how bright the lights appear, depends on how many particles are precipitating into the atmosphere and how much energy they're carrying. During quiet times, when solar wind activity is low, only a gentle drizzle of particles enters the atmosphere, creating faint, diffuse auroral glows or thin arcs. During geomagnetic storms, when magnetic reconnection in the magnetotail accelerates vast numbers of particles to high energies, the particle precipitation intensifies dramatically, and the auroras become brilliant, filling the sky with bright, rapidly moving curtains and rays. The curtain-like structure of auroras, those vertical sheets of light, hang like cosmic drapes, reflects the geometry of Earth's magnetic field. The field lines converge toward the poles, and particles spiraling along these lines create elongated vertical structures aligned with the field direction. When you see an aurora curtain, you're actually seeing a cross-section through a sheet of light that extends along a magnetic field line, perhaps thousands of kilometers long but only a few hundred meters thick in the direction perpendicular to the field. The shimmering, dancing motion of auroras comes from variations in the particle precipitation. The solar wind isn't steady, It varies in density and velocity on timescales of seconds to minutes. The magnetosphere responds to these variations, and the particle flow into the atmosphere fluctuates accordingly. Reconnection events in the magnetotail can suddenly release bursts of particles. Waves in the magnetosphere can modulate the particle flux. All of this creates the dynamic, ever-changing character of auroral displays. Sometimes the aurora pulsates, brightening and dimming rhythmically with periods of a few seconds. This pulsation is thought to be caused by waves in the magnetosphere, oscillations in the magnetic field and plasma density that modulate the particle precipitation. The waves act like a valve, periodically opening and closing the flow of particles into the atmosphere, creating the observed pulsations in the auroral light. Occasionally, during very intense displays, observers report hearing sounds associated with auroras, faint crackling, rustling, or whooshing noises that seem to coincide with rapid auroral motion. These reports have been controversial because auroras occur at altitudes far too high for sound to travel downward to ground level. Recent research suggests the sounds might be produced locally, perhaps by electrical discharges in the very low atmosphere or at ground level, triggered by intense electrical currents associated with strong auroral activity. The mechanism isn't fully understood, but the reports persist, adding another layer of mystery to the auroral experience. The total light output of an aurora can be substantial. A bright aurora might emit as much light as a full moon spread across the sky, enough to read by if the aurora is intense and you're in an otherwise dark location. Yet despite this brightness, auroras are ghostly translucent. You can see stars through even bright auroral curtains because the light is emitted over such a large volume of space. The aurora isn't a surface reflecting light, but rather a volume emission, light created throughout hundreds of kilometers of altitude, giving it a distinctive ethereal quality. Understanding the physics of auroral light creation doesn't diminish the wonder. If anything, it enhances it. You're watching quantum mechanics in action, seeing individual atoms transitioning between energy states, witnessing the conversion of kinetic energy into electromagnetic radiation. Each photon you see traveled from an atom 100 or 200 kilometers overhead, was created by the interaction between a solar wind particle that left the sun days ago and an atmospheric atom that has been part of Earth's atmosphere for who knows how long. The light carries information encoded in its wavelength, green telling you oxygen atoms at 100 to 150 kilometers, red suggesting oxygen at very high altitude, blue and purple indicating nitrogen excitation. The brightness tells you about particle flux and energy. The motion reveals magnetospheric dynamics. Aurora is simultaneously beautiful art and scientific data, aesthetic experience and physical process. Rest now in the image of these countless atomic emissions, creating curtains of light. Picture each atom excited by collision, holding that excess energy briefly, then releasing it as a photon that travels at light speed to reach an observer's eye, to create the experience of aurora. Billions of atoms doing this simultaneously, creating light from darkness, beauty from physics, wonder from understanding. Let the patient pace of atomic processes, excitation in nanoseconds, emission in fractions of a second, repeated countless times, create a meditative rhythm in your mind. Each atom doing its small part, each photon contributing to the whole, all of it adding up to the magnificent displays that have inspired humans for millennia. Breathe slowly, imagining photons of green light traveling down from the auroral oval, carrying energy released by oxygen atoms returning to rest. Let yourself return to rest as well, relaxed, peaceful, eased by the understanding that beauty emerges naturally from the physics of our universe, that light is created constantly in the atmosphere above, that the dance continues whether we watch or not. For as long as humans have lived at high latitudes, and that's tens of thousands of years, stretching back through countless generations into the depths of prehistory, they have watched the auroras dance across their night skies, long before we understood the physics of charged particles and magnetic fields, long before we knew about the solar wind or atmospheric chemistry. People witnessed these lights and wondered. They created stories to explain what they saw, myths that wove the aurora into their understanding of the cosmos, the spirit world, and humanity's place in the universe. Let us travel now, not through space, but through time and culture, exploring how different peoples have perceived and interpreted the auroras. These stories aren't mere primitive superstitions to be dismissed now that we have scientific explanations. Rather, they're beautiful expressions of human wonder, profound attempts to understand mysterious phenomena, and windows into how our ancestors related to the natural world around them. Begin in the Arctic, among the Inuit peoples who have lived in the northernmost regions of North America for thousands of years. The Inuit had many names for the Aurora Borealis, and their explanations varied somewhat between different groups across the vast Arctic territory. But common themes emerge from these stories. Themes of the spirit world, of ancestors, of powers beyond ordinary human experience. Many Inuit traditions held that the auroras were spirits of the dead playing games in the sky. Some stories describe the spirits playing a ball game with a walrus skull, the lights being the torches they carried to see the playing field. Others spoke of the spirits dancing, celebrating in the afterlife, their movements creating the shimmering curtains of light visible to those still living on Earth. Still others warned that the spirits might be dangerous. Some traditions advised children to stay indoors during bright auroral displays, or to be quiet and respectful, lest they attract the spirits' attention. There was often an element of communication in these beliefs. Some Inuit groups believed you could summon the aurora by whistling to it, or make it come closer by waving a white cloth. The aurora might respond to human actions, brightening or moving in response to calls. Whether this was literally believed or understood as poetic expression varied, but it reflects a sense of relationship between humans and the aurora, a feeling that the lights were not merely atmospheric phenomena, but entities that could interact, respond, be engaged with. The Sami people of northern Scandinavia, the indigenous inhabitants of the region covering northern Norway, Sweden, Finland, and Russia's Kola Peninsula, also had rich aurora traditions. The Sami languages have multiple words for the aurora, reflecting their importance in Sami culture. One traditional belief held that the auroras were the energies of the souls of deceased virgins dancing in the sky. The Sami were often cautious about the aurora, treating it with respect and sometimes fear, especially during particularly intense displays. Some Sami traditions prohibited speaking loudly or singing when the aurora was visible, and certainly one should not mock or disrespect the lights. There were stories of auroras descending to capture disrespectful people, or of the lights causing misfortune to those who didn't show proper respect. These weren't necessarily stories of malevolent spirits, but rather recognition that the aurora represented powerful forces worthy of reverence. The Finnish name for the aurora, revontulet, meaning firefox lights, comes from a different kind of story. Finnish folklore spoke of a magical fox running across the snow-covered fells of Lapland, its tail sweeping snow crystals up into the sky where they caught the light and created the shimmering displays. Some versions had the fox striking rocks with its tail, creating sparks that illuminated the sky. This beautiful image, a fox racing across the Arctic landscape, its tail painting lights across the heavens, captured something of the aurora's graceful sweeping motion across the Atlantic to North America, and we find more aurora traditions among First Nations peoples. The Cree, whose traditional territories stretched across central Canada, had their own interpretations. Some Cree traditions held that the aurora was a way for the spirits to communicate with the living, to send messages, to make their presence known. The dancing lights might be ancestors trying to tell their descendants something important, warnings or blessings carried on the shimmer of green and red. Other North American indigenous groups had different perspectives. Some saw the aurora as a good omen, a sign of coming success in hunting or warfare. Others viewed it with apprehension, seeing in the blood-red auroras that sometimes occur a portent of violence or conflict. The interpretation often depended on the aurora's color and behavior. Gentle green curtains might be seen as benign or positive, while rare all-sky displays of red aurora could inspire fear. The Norse people of Scandinavia, though not indigenous in the sense of being the first inhabitants, that distinction belongs to the Sami, developed their own rich mythology around the aurora. In Norse cosmology, the aurora was believed to be the Bifrost, the rainbow bridge connecting Midgard, the world of humans, to Asgard, the realm of the gods. The Bifrost was guarded by Heimdall, the watchman of the gods, and the souls of fallen warriors would cross this bridge to reach Valhalla. Another Norse interpretation associated the aurora with the Valkyries, those warrior maidens who chose which soldiers would die in battle and escorted the chosen to Valhalla. The shimmering lights were said to be reflections from the Valkyries' armor as they rode across the sky on their missions. This imagery, divine warriors riding through the heavens, their armor gleaming, captured the aurora's martial quality, the way bright displays can resemble spears or swords of light pointing toward or away from the zenith, traveled to the southern hemisphere, to the lands where the aurora australis, the southern lights, are visible. The Aboriginal peoples of Australia, particularly those from the southern regions, had their own aurora stories. Some traditions held that the southern lights were fires lit by the spirits in the far southern lands, perhaps campfires of ancestors or the glow of spiritual gatherings. Given that the aurora australis is most commonly seen from high southern latitudes, Antarctica, southern New Zealand, southern Australia, southern South America, it was a less frequent phenomenon for most Aboriginal groups than the aurora borealis was for Arctic peoples, but still notable when it appeared. The Maori people of New Zealand at higher southern latitudes would have seen the aurora australis more regularly. Maori traditions spoke of Tahu Nui Arangi, great burning in the sky, and associated the lights with fires or torches. Like many aurora traditions worldwide, there was an element of the spiritual, a sense that these lights represented something beyond the ordinary material world. What's striking about these diverse traditions from cultures separated by vast distances and thousands of years is their common threads. Almost universally, the aurora was seen as something spiritual or supernatural rather than purely material. It often involved the spirits of the dead, ancestors, or divine beings. It inspired both wonder and caution. The aurora was beautiful but also powerful, worthy of respect, not to be treated carelessly. This makes perfect sense given what our ancestors could observe. The aurora appears suddenly, without obvious cause. It moves in ways that seem purposeful, dancing, waving, pulsating, suggesting agency or intentionality. It's silent, creating no sound despite dramatic visual motion, which makes it eerie, otherworldly. It occurs high in the sky, in the realm between earth and heavens, in the space associated with gods and spirits in many cosmologies. And it's beautiful, achingly, hauntingly beautiful in ways that demand explanation, that cry out for meaning. The scientific understanding we have today doesn't erase these older meanings. Instead, it adds another layer. Now we know the aurora is both spiritual metaphor and physical phenomenon. It represents the interaction between Earth and Sun, the protection provided by the magnetic field, the chemistry of the atmosphere. But it also remains what it always was to human observers, a source of wonder, a reminder of powers greater than ourselves, a connection to something vast and mysterious. There's wisdom in the traditional stories that science alone doesn't capture. The indigeno, us emphasis on respect, on treating the aurora with reverence, on not mocking or disregarding it, reflects a relationship with nature based on humility and reciprocity. The stories of ancestors and spirits dancing in the sky speak to human needs for connection with those who came before, for understanding death, not as ending, but as transformation. The sense of communication, of messages being sent through the aurora, suggests an alive and responsive cosmos rather than a dead mechanism. Modern aurora observers, even armed with scientific understanding, often report profound emotional and spiritual experiences when witnessing particularly spectacular displays. There's something about standing beneath curtains of light that dance across the entire sky, that move with seeming purpose, that appear in colors impossible to fully capture in photographs, that induces awe and wonder regardless of whether you interpret them as spirits or as atmospheric physics. Perhaps the deepest wisdom is recognizing that both interpretations can coexist. The aurora is solar wind particles colliding with atmospheric oxygen and nitrogen atoms, and the aurora is also a reminder of our connection to the cosmos, a visible manifestation of invisible forces, a source of beauty and wonder that transcends purely material explanation. Science tells us how the aurora works. The stories tell us what it means. The experience of watching an aurora remains fundamentally the same across time and culture. The Inuit hunter watching from the sea ice thousands of years ago, the Norse warrior interpreting the lights as Valkyries, the modern scientist with magnetometers and spectrometers, the tourist in Iceland with a mirror. All of them look up at the same phenomenon. All experience wonder at the dancing lights. All are participating in a human tradition of aurora observation stretching back into prehistory. There's something deeply comforting about this continuity. The auroras that danced in the sky for your ancestors dance there still, The lights that inspired ancient stories continue to inspire modern observers. The same physics that created auroras a billion years ago creates them tonight. You're part of an unbroken chain of observers connected through time by shared wonder at these lights at the edge of night. Rest now in that connection. Feel yourself part of humanity's long relationship with the aurora, part of the tradition of looking up and wondering, part of the continuity that stretches from ancient past into distant future. The aurora danced for countless generations before you, and will dance for countless generations after, unchanged and unchanging, a reliable constant in a changing world. Let this timelessness ease you towards sleep. The aurora asks nothing of you except perhaps attention and appreciation. It appears whether you watch or not, creates beauty whether you understand or not, continues its ancient dance driven by forces as old as the solar system itself. You can rest peacefully knowing that some things persist beyond human concerns, that beauty continues to be created naturally, that wonder is always available to those who look up. Breathe slowly, imagining yourself beneath shimmering curtains of green light, connected to all who have ever watched the aurora, part of the long human story of seeking meaning in the night sky, finding peace in the knowledge that, oh, mysteries remain, even as others are explained. We arrive now, at the end of our journey through the aurora's story, at the place where we can step back and contemplate the larger meaning, the deeper comfort that understanding this phenomenon can provide. Let us rest here together and consider what it means that auroras have been occurring for billions of years, will continue for billions more, and represent a fundamental constant in our dynamic relationship with the sun. The aurora is ancient beyond human comprehension. As soon as Earth developed a magnetic field, which happened early in our planet's history, probably within the first few 100 million years after formation, and as soon as there was an atmosphere with oxygen and nitrogen, the conditions existed for auroras to occur. This means auroras have been dancing in Earth's polar skies for at least 3.5 billion years, perhaps longer. Think about that time scale for a moment. 3.5 billion years ago, life on Earth was just beginning. Simple single-celled organisms, bacteria, nothing remotely like the complex multicellular life we know today. The continents were different, perhaps smaller, the ocean chemistry different, the atmosphere different, less oxygen, more carbon dioxide. But the auroras were there, shimmering above seas that no eye had yet evolved to see them, creating beauty witnessed by no one through all the subsequent transformations of Earth, through the rise of photosynthetic organisms and the great oxidation event that changed the atmosphere, through the evolution of complex cells and then multicellular life, through mass extinctions and evolutionary radiations, through the rise and fall of countless species. The auroras continued. They danced above the Cambrian seas teeming with strange arthropods. They glowed in the skies above carboniferous forests. They illuminated the Cretaceous world of dinosaurs. They flickered above the ice sheets of the Pleistocene. The auroras witnessed all of Earth's history, constant and unchanging in their fundamental nature, even as everything beneath them transformed. They were there before anything could see them, and will be there long after anything remains to see them. They are not dependent on life or consciousness or observation. They simply are a natural consequence of our planet's structure and position in the solar system. And they will continue, for as long as the sun continues its main sequence lifetime, about 5 billion years more, it will produce the solar wind. For as long as Earth's core remains molten and convecting, which should be several billion years at least, Earth will generate a magnetic field. For as long as Earth has an atmosphere containing oxygen and nitrogen, which should persist until the sun's increasing luminosity eventually boils away the oceans and stabilizes the atmosphere perhaps a billion years from now, the chemical ingredients for auroral light will exist. This means auroras will continue appearing in Earth's skies for at least another billion years, possibly several billion. That's a time span that dwarfs all of human history by a factor of thousands or millions. We've been watching auroras for perhaps 50,000 years of modern human existence. They'll continue for 20,000 times that long before changing solar conditions finally bring the show to an end. There's something profoundly peaceful about contemplating this constancy. In a world where everything seems uncertain, where change happens rapidly, where human concerns and crises dominate our attention, the aurora represents something absolutely reliable. The physics doesn't change. The solar wind keeps flowing. The magnetic field keeps protecting. The atmospheric atoms keep emitting light when excited. The process continues day after day, year after year, millennium after millennium, regardless of human affairs. The aurora doesn't care about politics or economics or social changes. It's not affected by human achievements or failures. It doesn't depend on what we do or don't do. It simply continues, a natural process operating according to physical laws that were established at the universe's beginning and will continue until its end. There's great comfort in this indifference, this reminder that the cosmos operates on scales and according to rules that transcend human concerns. Consider also that Earth is not unique in experiencing auroras. Other planets in our solar system have them too, each displaying variations based on their particular conditions. Jupiter has spectacular auroras, far more energetic than Earth's, powered by the giant planet's rapid rotation and strong magnetic field. Jupiter's auroras are visible in ultraviolet light from space-based telescopes, glowing brilliantly at both poles, fed not just by solar wind, but also by material from Jupiter's volcanic moon Io. Saturn also has beautiful auroras, captured by spacecraft in both visible light and ultraviolet. Saturn's auroras are influenced by the planet's magnetic field and by interactions with its rings and moons. Uranus and Neptune, despite being far from the Sun and receiving weak solar wind, also generate auroras. Even Mars, which lacks a global magnetic field, experiences localized auroral displays associated with patches of magnetized crust in the southern hemisphere. Beyond our solar system, astronomers have detected auroras on brown dwarfs, objects between planets and stars in mass, and theoretical models suggest auroras occur on exoplanets orbiting other stars. Anywhere you have a magnetic field, an atmosphere, and a source of charged particles, whether from a host star or from interactions with moons, you can have auroras. The phenomenon is universal, a natural consequence of electromagnetic physics that must occur throughout the cosmos. This universality is both humbling and connecting. When you watch an aurora, you're witnessing a phenomenon that occurs throughout the universe, on countless worlds, orbiting countless stars. You're seeing something that's not unique to Earth, but rather is a common feature of planetary systems, and yet each aurora is also unique. The specific dance of light you see on any given night has never occurred before exactly that way, and will never occur again. a unique configuration of solar wind conditions, magnetic field geometry, and atmospheric interactions. The aurora thus bridges the universal and the particular, the eternal and the momentary. It's both a timeless cosmic process and a fleeting display, both ancient and new, both common throughout the universe and unique in each manifestation. This duality, permanence and change, universality and uniqueness, makes the aurora a perfect subject for meditation, for contemplation, for finding peace. There's wisdom in observing natural phenomena that operate independently of human concerns. Modern life encourages us to believe that everything important revolves around human decisions, human actions, human meaning-making. But the aurora reminds us that vast processes operate without any reference to humanity. The sun produces solar wind not for us, but simply because that's what stars do. Earth's magnetic field exists not to create beautiful displays, but as a consequence of planetary structure and thermal history. The lights appear not as entertainment, but as inevitable outcome of physics and chemistry. Recognizing this helps us situate ourselves more accurately in the cosmos. We're not the center, not the purpose, not the audience for which the show is performed. We're simply fortunate enough to live on a planet where these processes occur, with sensory systems capable of perceiving the visible light produced, with minds capable of appreciating the beauty and understanding the causes. We're witnesses to something that would happen with or without us, and there's freedom in that recognition, freedom from the burden of believing everything must relate to us. The aurora also demonstrates the interconnectedness of cosmic systems. It requires the sun to produce solar wind, Earth to have a magnetic field generated in the core, the magnetosphere to guide particles, the atmosphere to contain the right gases, and evolution to have produced oxygen over billions of years. It's not a single thing, but rather a complex outcome of multiple systems interacting. This interconnectedness is characteristic of nature. Everything affects everything else. Nothing exists in isolation. All processes are embedded in larger contexts. Understanding this interconnectedness cultivates humility and appreciation. The green light you see in an aurora exists because early cyanobacteria, billions of years ago, produced oxygen as a waste product. Because Earth was large enough to retain that oxygen. Because the planet's core remained molten. Because the sun has a particular structure that generates solar wind. Seeing the outcome of billions of years of planetary and stellar evolution all coming together in that moment of light emission. For those who have witnessed truly spectacular auroral displays, all sky auroras where the entire sky fills with dancing light, where curtains stretch from horizon to horizon, where colors shift rapidly from green to red to purple, where the lights seem to descend until you feel you could reach up and touch them. The experience is often described as spiritual or transcendent. Even with scientific understanding, even knowing the physics involved, the visceral experience of standing beneath such a display induces feelings of awe, wonder, and connection to something larger than oneself. This is appropriate. You are connecting to something larger, to the sun and its constant output of energy and matter, to Earth and its protective magnetic field, to the atmosphere that makes life possible, to the long history of planetary evolution that had created current conditions, to the countless humans across time who have also looked up at these lights and felt wonder. The aurora is a nexus point, where multiple cosmic processes intersect and become visible, where the normally invisible interactions between Earth and space manifest as beauty, There's also something fundamentally calming about the aurora's motion. Unlike the frenetic pace of modern life, auroras move at their own rhythm, sometimes quick and darting, sometimes slow and stately, but always following patterns dictated by magnetospheric dynamics rather than human concerns. You cannot make an aurora move faster or slower, appear brighter or dimmer through any act of will. You can only watch, observe, allow the lights to dance at their own pace. This enforced passivity, this requirement to simply witness rather than control, has meditative qualities. In our daily lives, we're constantly trying to influence outcomes, control situations, make things happen according to our preferences. But with the aurora, all you can do is watch. And in that watching, in that surrender of control, there can be profound peace. The silence of auroras contributes to their contemplative quality. Despite the dramatic visual display, despite the sense of motion and energy, despite what seems like it should be accompanied by sound, there is silence. The aurora occurs at altitudes where the air is too thin to carry sound. What you see is happening in effective vacuum, creating light but no sound, motion but no noise. This disconnect between the visual and auditory creates a dreamlike quality, reinforcing the aurora's otherworldly character. As we conclude this exploration, let these understandings settle into your awareness. The aurora is ancient, constant, universal, and yet unique in each manifestation. It operates independently of human concerns, yet offers beauty and meaning to those who observe it. It connects earth to sun, present to past, the visible to the invisible. It asks nothing of you except perhaps attention, offers gifts of beauty and wonder, continues whether you watch or not. Tonight, somewhere on earth, the aurora is dancing, perhaps in the Arctic, perhaps in Antarctica, perhaps visible from Norway or Alaska or New Zealand or Tasmania. The same process we've traced, solar wind particles spiraling down magnetic field lines, colliding with atmospheric atoms, exciting electrons, producing photons of green and red and purple light, is occurring right now, creating beauty that someone may be watching, or that may be dancing unseen above clouds or over unpopulated regions. And tomorrow night, the aurora will dance again, and the night after that, and for 1 billion years more, until the sun's changing nature finally ends Earth's aurora era. But that's so far in the future that it needn't concern you. For now, for your lifetime, for countless generations to come, the auroras will continue their ancient dance, constant and reliable, a source of wonder available to those who venture to high latitudes and look up. Rest now in this knowledge. Feel yourself connected to the long chain of aurora observers stretching back into prehistory and forward into the distant future. Feel yourself part of the cosmos, living on a planet that participates in solar system dynamics, protected by a magnetic shield that transforms potential harm into luminous beauty. Feel yourself held safely within Earth's protective embrace, the magnetosphere operating invisibly above you whether you're aware of it or not. The processes that create auroras continuing their patient work. Let the image of the aurora, curtains of green light dancing silently across a dark sky, stars visible through the translucent glow, the lights moving to their own rhythm unconcerned with human time, ease you into sleep. Let the constancy of the phenomenon, its continuation across billions of years, its indifference to human concerns bring peace. Let the beauty of light created by atomic processes, the elegance of physics made visible, the wonder of interconnected cosmic systems all working together, quiet your mind, breathe slowly, deeply, matching your rhythm to the patient pace of cosmic processes. The solar wind flows. The magnetic field protects. The atmospheric atoms await their collision with energetic particles. Light will be created, beauty will emerge, the dance will continue, and through it all you can rest, secure on your protected planet beneath your invisible shield, held safely while the auroras dance and the cosmos continues its ancient rhythms. Sleep well, knowing that some things endure. Some processes continue. Some beauty persists across timescales that make human lifetimes seem like single breaths. The aurora danced before you were born and will dance after you're gone, connecting you to deep time, to cosmic processes, to the long story of matter and energy in the universe. Rest now. The lights are dancing. Let them dance you into dreams. Good night.